Welcome to the video lecture series on engineering mechanics. As part of third unit, centroid and center of gravity. In this video, we will be covering the derivation of centroid of rectangle. Consider a rectangle of breadth B and depth D as shown in the figure. The area of the rectangle capital A is given by B into D, breadth into depth. Let xy be the reference axis for locating the centroid of the rectangle. Here I am considering the reference axis xy axis like this. The x-axis is at the bottom of the rectangle and y-axis is taken as the left side edge of the rectangle, so that the total rectangle will lie right side of the axis, and the bottom left corner will be the origin for the axis. With reference to this origin and with reference to this coordinate system, now we are going to derive the centroid location, or we are deriving the formula for x bar and y bar, which we have derived in the previous video lecture. Consider a small rectangular strip whose width is dx and at a distance of x from the y-axis as shown in figure. See, this is the rectangular strip. Its width is dx and it is at a distance of x from y-axis. Now, the area of the small strip dA is equal to d into dx. Here we haven't changed the depth. The depth of the strip is d itself, we haven't changed, but we have considered a small portion of it whose width is dx. Therefore, d into dx, it is a rectangular strip. The height of the rectangle is d and its width is dx. The area is given as d into dx. Now, in the integral form, the coordinate of centroid is given by ax bar is equal to integral x dA, where A is the total area of the given shape. Here the shape is rectangle, the area is BD, which we have already seen. Now, the x in the formula is the distance of the strip from y-axis. That is, we have considered x itself in this derivation. Now, ax bar is equal to integral 0 to b x into dA. Here I am substituting the limits 0 to b, because the rectangle area is formed by placing so many vertical strips of width dx side by side from 0 to b. That's why the integration limits are 0 to b. Now substitute the remaining values. Ax bar is equal to integral 0 to b x into d dx. D dx is the area and x is the distance of the strip from y-axis. Ax bar is equal to, complete the integration. Here d is constant for all the strips, so d will be taken out of the integration. X dx integration is dx square by 2 and the limits are 0 to b. Now substitute the upper limit in place of x first minus the lower limit. Ax bar is equal to db square by 2, substituting b in the place of x, db square by 2 minus 0. If we substitute lower limit 0 in place of x, the total entire term becomes 0. So finally, ax bar is equal to db square by 2. Now, x bar is equal to db square by 2a, where a is BD, area of the rectangle, db square by 2bd. Here b and 1b is cancelled and d and d in the numerator is cancelled. The final expression or equation or formula for finding the x coordinate of centroid of rectangle is b by 2. the center of rectangle lies at a distance of half of its width. X bar is equal to b by 2. Now this is the point and it is at a distance of b by 2 from the origin measured along x axis. Now similarly let us find y bar. For that consider a small strip, rectangular strip dy. Consider a small rectangular strip dy at a distance of y from x axis. Now here I am taking a horizontal strip whose depth is dy and width is same b, width we are not changing b, and it is at a distance of y from x axis. Area of the small strip considered dA is equal to now b into dx. B is the width of the strip and dy is the depth of the strip. The formula for finding the center of centroid in integral form is a y bar is equal to integral y dA. Now substitute the values here. A y bar is equal to integral 0 to d by dA. Here the limits are 0 to d. Let us look at the diagram. The rectangle entire area will be formed by placing the strips which we have considered, small strips, one above the other from 0 to d. That's why the limits are from 0 to d. Substitute the remaining values. A y bar is equal to integral 0 to d y into b dy. Here y is the distance of the strip considered from x axis. In this derivation we have considered the distance is y itself. So y into b dy. A y bar is equal to, here in the integration b is constant and y dy integration is y square by 2. B into y square by 2, 0 to d. Now substitute the upper and lower limits. A y bar is equal to b d square by 2 and 0. The final expression for a y bar is b d square by 2. Now y bar is equal to b d square by 2 divided by 2a, the area of the rectangle. A is the area of the rectangle which is given by bd. Now the b is cancelled and 1d is cancelled. Finally y bar expression is d by 2. Now the location or the coordinate values of centroid of rectangle for this coordinate system, only, where the lower bottom edge is taken as origin, is b by 2 and d by 2. B by 2, d by 2. Measured along x axis, b by 2 half of given width and d by 2 half of given depth. The centroid coordinates x bar y bar for rectangle is b by 2 and d by 2. In this video lecture, we have seen the first moment of area gives us the centroid. The formula in integral form for finding the centroid x coordinate is ax bar is equal to integral x dA, and we have find the rectangle's centroid is at a distance of b by 2 along x axis and d by 2 along y axis. Thank you.